Year 11, homework 11, mainly about the atmosphere. We've got a bit of a calculation at the end. So if you can't remember this, it's go and look at your core knowledge is my best advice. Go look at the core knowledge section or go back to the atmosphere section when we taught it. Just to quickly help with some of these, I'm not writing the answers out because that's your job, and you can find the answers in the core knowledge, or if you go back to the pages when we did this, but I'll quickly talk through some of this to help you. Gas in the first atmosphere. The first atmosphere was formed from the gases that came out of volcanoes. Volcanoes predominantly giving out carbon dioxide and water vapour, of course. Why can we not be certain of the makeup of the Earth's original atmosphere? Mainly because the human race had not evolved until many hundreds of thousands of years. I mean, the Earth is 4.5 billion years old, so it's billions of years after the Earth's first atmosphere was here. So we are making judgments about the Earth's early atmosphere, original atmosphere, from data from rocks, or maybe later in geological time using ice cores from the Antarctic. Basically, it snows in the Antarctic every year. When the snow falls, it traps parts of the atmosphere in between the snowflakes. Over time, it never melts because it's the Antarctic, it's very cold, so every year it snows on top of last year's snow. So this traps atmosphere from hundreds of thousands of years ago in the ice. So if you mine it out, drill it out, you can melt the ice from hundreds of thousands of years ago and get a little record of the atmosphere from that time. So basically humans weren't living then. Okay. How was oxygen added to the atmosphere? Oxygen was not in the original atmosphere. Oxygen is 21% of our atmosphere today. And of course, every animal needs it to respire, so it's crucial. But it wasn't in the Earth's first atmosphere. How was it added? It was from the evolution of plants and photosynthesis. Why did the carbon dioxide in the Earth's early atmosphere decrease? So lots of carbon dioxide came out of volcanoes. So the Earth's early atmosphere had lots of carbon dioxide in it. Now today's atmosphere has 0.04% carbon dioxide, so it's decreased markedly. So why did it decrease? Two answers. Number one, it's dissolved in the oceans. It dissolved in the water. Dissolved in liquid water on the Earth's surface. Once in the oceans, it can be locked up into carbonate rock formations. So deposited at the bottom of the sea as calcium carbonate, things like that. So that locked up large amounts of carbon dioxide. And of course, when green plants evolved, photosynthesis, and plants take carbon dioxide in, along with water from the roots, and turn it into glucose. So in other words, it can be stored in the plant as wood or whatever else, and give off oxygen. And the giving off oxygen is how the oxygen started. Was entered into the atmosphere. What is leading to an increase in the amount of carbon dioxide in the atmosphere today? Well, that's several things leading to an increase in the amount of carbon dioxide. There's directly leading to an increase in carbon dioxide is burning of fossil fuels. Also, animals respiring. I mean, the number of the global population of humans has been increasing steadily for the last couple hundred years. So, but predominantly it's the burning of fossil fuels. Indirectly, we've got deforestation going on. So cutting a tree down doesn't add to the amount of carbon dioxide in the atmosphere straight away, but what it does is it stops that tree from removing the carbon dioxide from the atmosphere. So that is deforestation as well. Next one, complete label. The charts show the gases make up current atmosphere. You may round the proportions to the nearest 10%. So current atmosphere, 20% carbon dioxide, 80% nitrogen, 1% other gases. So the 1% other gases is in. We've got a pie chart here, 5 segments. Okay, so roughly 1 segment, I suppose, is going to be oxygen. So draw that. Complete table to show a difference between global warming and acid rain. Okay, so global warming, gas responsible for that is carbon dioxide from burning fuels. Basically, we've got the Earth here. We have our Earth. Okay, the carbon dioxide. The atmosphere forms is around the outside. Okay, now nitrogen and oxygen, which is the gases mainly in the atmosphere, is like a summer duvet that we pull over ourselves at night. Okay, it's great in the summer but doesn't cut it in the winter. Okay, basically when we have the sun here, okay, the sun shines its infrared heat onto the Earth during the day, and then at night the Earth loses that infrared radiation. So the oxygen and nitrogen, like a summer duvet around the Earth, and it kind of lets lots of that infrared radiation escape. So in other words, the Earth cools down at night. You put carbon dioxide into that atmosphere, or methane. This is like putting a winter duvet around the Earth. So what it does is it stops that infrared radiation leaving at night. It gets trapped in the atmosphere, bounces around. This leads to the Earth warming up. Okay, eventually some of it will escape. But adding carbon dioxide and methane and water vapour, 3 gases responsible: carbon dioxide, methane, water vapour. Adding those to the atmosphere, it warms up the planet. Acid rain, on the other hand, is completely different. All right, and people get these confused. So there's 2 main sources of acid rain: sulfur dioxide. Sulfur dioxide is a gas responsible. Sulfur dioxide and nitrogen oxide. Sulfur dioxide, I'll talk about that one. Made in coal burning power stations. So a coal burning power station is a great source of sulfur dioxide. Now we've phased these out in the UK, but in China there's loads of them still. Coal burning power stations. Coal is predominantly 99% carbon, but say it's 1% sulfur. These are rough estimates, okay? But the point I'm trying to make is coal has some sulfur in it. So when that's burnt, it makes sulfur dioxide. Sulfur dioxide comes out of these chimneys here, SO2. Sulfur dioxide goes into the clouds. Clouds are water vapour, H2O vapour. As soon as the sulfur dioxide goes into there, it makes sulfuric acid. Sulfuric acid, okay? That then gets blown somewhere else and it rains. And this therefore is acid rain. So coal burning power stations can make that, and cars can as well. The car sucks air into the engine. When the car sucks air into the engine, it's sucking nitrogen and oxygen in. Okay, the car engine is so hot that some of the nitrogen combines with the oxygen to make nitrogen oxide. Nitrogen oxide goes into the cloud and makes nitric acid. Okay, so that's acid rain, those 2. Solutions, you need to know solutions to the greenhouse effect. So the solutions are to stop deforestation. The solution is to become less reliant on fossil fuels that produce carbon dioxide when they burn. So we need things like fuel cells, okay, that use hydrogen and react with oxygen to make water and electricity. These are our solutions. Finally, a calculation. What's the relative atomic mass of a sample of thallium that is comprised 30% thallium-203 and 7% thallium-205? Right, if you haven't learned this formula, percentage times mass plus percentage times mass, you have no chance. This is year 10, topic 1. It's the first calculation we did. And you need to divide that by 100. So you need that written out in your homework. Okay, if you don't have that written out, you can't have one of these 3 marks. We then need to substitute in these numbers. So we've got 30%. Okay, this isn't thallium minus 203, this is thallium 203. This is the mass number. So if you look on the periodic table, it will be written like that, 203. Okay, that's just how we write the mass number. So mass 203, 30 times 203. Okay, plus, now you need to substitute the other numbers in there, plus percentage times mass. Yeah? So you substitute those numbers in there. All right, brackets you need to work out first, so get your calculator. Let's divide by 100. Get your calculator, put in 30 times 203, okay? 30 times 203 equals 6,090. Work out that bracket, so I want you to write 6,090 plus, you work out that bracket, put it there, then divide by 100, then add them together, divide them by 100, and that will be your answer, okay?